In this lecture, we will be talking about concentration units in water. Typically speaking, concentration units are expressed as mass over volume, mass over mass, moles over moles, or volume over volume. So examples of mass over volume, so it could be milligrams per liter, could be milligrams per meter cubed. Sometimes it could also be moles per liter. That's also an indirect form of mass per volume. And moles per liter is denoted by uppercase M for molar. Then mass per mass can be, for example, milligram per kilogram. It could be ppm to the base m, ppb to the base m. The subscript m denotes that this is on a mass basis. Could be moles per kg. And moles per kilogram is sometimes called molal, denoted by lowercase m, although we're not going to use it a lot. It's not a frequently used unit. And then this is simply the mole fraction. And this is volume fraction. For example, ppmv. So this denotes its, or ppbv. This is on a volume basis. And these are primarily used for gases. So we won't be using a lot of these for water, and we use mostly these first two for water. Let's take some quick examples. So let's see. For say mass over mass, let me just write down a quick example. Say you have 1 kilogram of soil sample, which contains half a milligram or 5 milligrams of a contaminant TCE trichloroethylene. So the question is, what is the TCE concentration in ppm m and ppb m? So how do we solve this? So for solving this, ppm on a mass basis is defined by mi over m total into 10 power 6. Mi is the species of interest, so in this case that would be 5 milligram. That would be 5 milligram divided by a kilogram. into 10 to the power 6. So that's 5 milligram divided by a kilogram. And now let's work the units. We know a milligram is same as 10 to the power minus 3 grams, and we know that 1000 grams make a kilogram. And then we also have this 10 to the power 6. So now some of these things would cancel. And we are left with 5 into 10 to the power minus 6 into 10 to the power 6 ppm, which is equal to 5 ppm. So that's our answer for this example. And for ppb, we can do the same thing. Except this is multiplied by 10 to the power 9. And if we solve this, you would get 5000 ppb. And yeah, these are subscript m. Okay. Now let's do an example for okay, before we move on to the example, I just want to make a note for aqueous solutions, meaning for water-based solutions, or for most water-based solutions, we can usually write milligram per liter as ppm, and we can also write microgram per liter as ppb. So these are pretty commonly used equivalents, but something to note, these are only for water and not for air or other liquids. Sorry, only for water. And you can quickly see why. It's based on the density of water. So we know the density of water is 1 gram per centimeter cubed, or 1000 gram per 1000 centimeter cubed is equal to 1 kilogram per liter. So now if we have 1 milligram per liter, we just said, and then we know that 1 liter is 1 kilogram, and we know that 1 milligram, or let's see, we can say that thousand milligrams make a gram, and 1000 grams make a kilogram. So if we cancel all the units here, we are left with so that's why a milligram per liter is same as 1 ppm, and same way 1 microgram per liter is same as ppb. It's only because of the density of water, which doesn't hold true for air. So a lot of times students make this mistake of using this conversion of milligram per liter as ppm or microgram per liter as ppb for substances other than water. Okay, let's take this example here. Oops. Yeah. So what are the molar concentrations of water in pure water? That seems kind of weird, but let's do this. What's the concentration of water in pure water? So, and we have to find the molar concentrations. So to do that, we can say that 1000 grams of water in 1 liter of water, we know that, and each mole of water is 18 grams, because how do we know that? Because H2O, H is 1, O is 16, so that would give 18 grams per mole, right? And if we calculate this, we get 55.5 moles per liter. So that's the concentration of water in water. Okay, let's do part B. Part B says to calculate the concentration of calcium, the molar concentration of calcium in a solution that contains 20 milligram per liter of calcium. So what we do for this is so remember that the atomic weight of calcium is 40 grams per mole. So 40 grams per mole, and then we know that a gram has 1000 milligrams. So if we calculate this and cancel out the units, so gram cancels with gram and milligram with milligram, so we left with moles per liter. So that's 20 over 40 is half, so 5 into 10 to the power minus 3 moles per liter, which is equal to 5 into 10 to the power minus 4 molar. Or I could also write it as 0.5 millimolar. They're all correct. Okay, let's do another example. If we want to calculate the concentration of silver, or if we are given the concentration of silver in seawater as 50 parts per trillion. So concentration of silver is 50 parts per trillion, and the volume of seawater in the world is 1370 into 10 power 6 kilometers cubed. That's a huge number. And the density of seawater is given as 1.025 kilograms per liter. And then the atomic weight of silver is grams per mole. Okay, so let's see. The question part A asks us how much total Ag or silver. So we know that Mi over M total into 10 to the power 12 is 50, where Mi is the mass of silver. So if we want the mass of silver, that would be 50 into 10 to the power minus 12 times M total, which is the total mass of seawater, and which would be M total would be the total volume of seawater divided by the density of seawater. So we could write that as and what's the total mass? It's V total. V total is given, or the V of seawater is given as 1370. So this is actually, you could say this is same as times okay, so let's try to get it in a reasonable unit. So a kilometer is 1,000 meters. So, and then 1,000 liter make a meter cubed. And then that's the density. Okay, so that's the VSW and rho SW. And now if we solve this, or So this is now 10 to the power 9 meter cubed divided by kilometer cubed. 10 to the power 3 liters divided by meter cubed, and 1.025 kilograms divided by liter. And if we start cancelling, units, that would be kilometers, cancels with kilometer cubed, meter cubed with meter cubed, liters with liters, and we are getting closer to what we need, a mass number. So this is and also you can notice that this 9, 10 to the power 9 and 10 to the power 3 is 10 to the power 12, which cancels with this. So we are left with which, if you punch into your calculator, I just did, is this number right here. Okay, now part B. Part B is asking us what volume of seawater would have to be processed to get a kilogram of silver if the process is 100% efficient. So you can see for getting 7 times 10 to the power 10 kilogram of silver, we need 1370 times 10 to the power 6 kilometer cubed. So for 1 kilogram of silver, we need 'this much volume of seawater. And if I just convert this to meter cubed, 10 to the power 9 meter cubed to a kilometer cubed. So we are left with so just simplifying this. So, or I could say about 19.6 million meter cubes. And if you take the cube root of this number, so you would see that this is equal to a cube of side 270 meters. So imagine a cube of seawater with each side measuring 270 meters, or a quarter of a kilometer. So about that much of seawater will need to be processed to get 1 kilogram of silver. Okay, last part of this problem. What is the PAG in the ocean? So using the P notation, so for that we have to first get the concentration in moles per liter. So we have the mass 7 into 10 power 10 kilogram, and we have 1370 times 10 to the power 6 kilometer cubed. And then we've just shown that a kilometer cubed is 10 to the power 9 meter cubed, and we've also shown that a meter cube is 10 to the power 3 liters. So that will give us, and then we can convert the kilograms to grams. 1000 grams make a kilogram. So that we solve gives us in grams per liter, but then we also need to convert the grams to moles. So 1 mole is about 108 grams. Now if I cancel, so I'm left with moles per liter. And if I solve this, I just put it in my calculator, and I get 4.73 into 10 to the power minus 10 moles per liter. So that's a concentration. Now to get PAG, we would need to take negative log to the base 10 of the Ag concentration. That would mean that so that would be this number right here, and if you solve this in your calculator, you would get an answer of 9.32. Okay, let's consider this next example where we want to express concentrations of ammonium and nitrate in terms of ammonium N and nitrate N. So basically what this means is ammonium N is the nitrogen coming from ammonium, and nitrate N is the nitrogen coming from nitrate. And so they are kind of both on the same baseline of the nitrogen units, so you could compare them and add them and so forth. Okay, and when we talk of ammonium N, so that means this is ammonium and there is only one nitrogen in ammonium, right? And same for nitrate. There is one N. And for ammonium, the total molecular weight is 14 grams. 14 plus 4, 18 grams. N is 14 grams and hydrogen is 1, so that makes it 18 grams per mole. And this is oxygen is 16. 16 times 3 is 48, plus 4 makes it 62 grams per mole. And nitrogen is of course 14 grams. So let's keep this information and then let's start solving it. So 30 milligram per liter ammonium. So 1 mole of ammonium has 1 mole of N, and because this N is from ammonium, we can call it ammonium N. And we just said 1 mole of ammonium is 18 grams, right? That's what we said right here. And then 1 mole of ammonium N is 14 grams. So it's pretty straightforward actually. It might look complicated, but it's not. So I'm just canceling out. So what we are left with is, and we could have written it actually straight away, but I wanted to show you. We could have just written directly. We have 14 grams of ammonium N in 18 grams of ammonium. So if we solve this, you will get 23.3 milligram per liter ammonium N. Let's call it part A, and then part B. Now we will do it in a straightforward way because I already explained the concept behind it. We have 5 milligram per liter of nitrate. So now we know that 14 milligram of nitrate N are in 62 milligrams of nitrate, because we have 1 mole of nitrate N in 1 mole of nitrate, and I just wrote their respective atomic or molecular weights, and we cancel these and then we solve for it. We will get 1.13 nitrate N. So now the question also asks us that which species makes a larger contribution to the total N. Well, if we compare the two, of course, it's very clear that ammonium makes a larger contribution.